Hey folks, welcome to another episode of ASP.NET Core from Zero to Overkill. In this episode we'll start building our backend for frontend, and we will be making a lot of use of .NET's HTTP client. So just to check out what we did before in the previous episode, we took a closer look at authorization, namely at roles, claims and policies, and a bunch of things in that regard. So authorize access to page using roles, authorize using policies by using a declarative way with attributes, and also Razor Pages conventions. And we checked out different ways to check if the policy is fulfilled by using some helpers like require claim. There are more, but we used require claim just to check it out. And implemented authorization handlers. In this episode, we'll go back to the frontend project, and we will be implementing the backend for frontend, or BFF for short. So we'll be creating a new web project. In this case, I already created it because we already know how to create it. I wanted to make it faster. And mostly what we will be doing is using the HTTP client to make requests to the group management service. So we'll briefly talk about how the HTTP client was used before ASP.NET Core 2.1. There were some problems, and now we have some helpers to try to help us avoid these kinds of problems. So we'll see how to configure the HTTP client in a ASP.NET Core application, and we will take a quick look at using Poly to implement a retry logic. So Poly is a library to help with improving resiliency of applications using a bunch of known patterns like retries, bulkhead, circuit breakers. So there's a bunch of things we can do with Poly, and we will check out a simple example. I have another video older on the channel that shows in more depth how to use Poly, not specific to ASP.NET Core. In this case, we will use the integration that the team created, but Poly is not dependent on this, and we can use for a lot of things. That's why I made a video some while ago. But be warned that the font is probably small. It was before I improved it in like I did in the latest episodes. So just why we are going with the backend for frontend. So if you don't know the pattern or what this means, it's simply to simplify the job of the frontend by, instead of making the frontend build everything it needs. So in our case, the Vue application making lots of requests to lots of different services, we can have an API on the backend that is made specifically for that frontend. So we can delegate the composition and all of that and more complicated stuff when we need to access more services than just one. We can delegate it to the backend, and the front-end application can be simpler. So the backend for frontend shouldn't have business logic. That should be on the other services that implement the logic. It should only have logic to ease the work of the frontend. In this case, we'll also take advantage of using the backend for frontend, so we can implement the authentication logic with less work for the frontend, and we can keep the secrets for authentication on the backend, which it's easier to secure, as we will see in this episode. Implementing the backend for frontend right now is kind of dumb, because the only thing we will be doing is proxying the requests to the group service, because this is really simple right now. But in the future, when we add complexity to the application, it should start to make sense, as we need to compose requests to different services to gather all the information to show, for instance, in a page in the front end. For cases like the current, where we only will basically proxy stuff, we will eventually take a look at ProxyKit and Ocelot. So ProxyKit is a library that helps us creating proxies in ASP.NET Core applications, and Ocelot is a library for creating API gateways. So this probably would help in cases like this where we just want to map the front-end request to another service. Because we want to play around with the HTTP client, we'll take a look at those later. Right now we'll do the simplest thing and look at the HTTP client making the requests on behalf of the front end. So, just before starting with the code, like I mentioned previously, if the videos are being useful, consider liking the video and sharing it. And probably the most important part, leave feedback so we can improve the videos. And why bother? Yeah, you know, it makes me know if the time investment is worth it, and with better metrics, hopefully YouTube will recommend the videos to more people. So now, let's get to code. Let's get to code or not, I think. Yeah, before I wanted to touch on the subject of the HTTP client with a bunch of articles, just a quick look. So probably you've noticed that the HTTP client, if you already used it, implements iDisposable. So probably our instinct is to create a new instance every time you want and dispose when we are done with it. And also maybe just using the using statement. The problem is the HTTP client, I won't go through the article right here, but for instance this would probably be what we would do. The problem is, even after we dispose the client, the connection is not closed immediately. It can take some time. So in the article they show all of this, the open connections and all of that, and they stay open. And this, like I mentioned, isn't a problem if the application hasn't too much load, because eventually the connections will close. But if we have a lot of load, eventually we can have port exhaustion because we use all the available ports. So this was a problem. One of the recommended solutions was to have a Singleton HTTP client, because the methods like the get async, put async, all of that are not are thread safe. Other methods, like if we change the base address or stuff like that, that is not thread safe, so we must be careful. But methods like this one are thread safe, so we can share the same client to make requests. Problem is, besides having to have this caution, by having a Singleton HTTP client, if there are DNS changes while the client is open, it won't see those changes. So there are lots of ways to do this, to configure, but it's not as easy as one would think would be. I will link the articles, but one just wants to new up a new HTTP client, make the request and be done with it. But it has some hidden problems. So in ASP.NET Core 2.1, if I'm not mistaken, they added some new features, namely the HttpClientFactory. I think there was already a class with that name or something like that, but this one is new, or at least a new implementation. And it takes care of all of that for us. So when we use this new factory and ask for a client, it will use a pool, so it will be able to use a connection, to reuse the connections to make the requests and all of that, without us having to worry that much about the HTTP client. In this case, I won't even use the HttpClientFactory directly. We'll use some helper methods that were added to register HTTP clients. But I'll leave these 3 articles linked in the video, so you can take a look if you want to know more about this, but we are going to use the HTTP client in the good way, hopefully. So I have already opened here the front-end application. Now let's start. I already created the project and made some configurations. Let me check. Where is this? Sorry, stop the video because the terminal went away. So I already created. So I created a server folder next to the client folder in the web frontend repository, and in here I created a solution for this back for front. So we can go to source, and we have here the web application. Over here I'm preparing to start the groups service. One note is that because we are starting another application, the default port is 5000 on both, so I'm going to start this one with a different URL. So 5002 will be the port used by the group management service. This will use the 5000 that is called by the front-end application. So let me start the group service. I already have the Postgres database up and running. Also the front end. So now let's take a look. I already added some things. So I added the API controller here and configured MVC and the compatibility version like we saw previously. So now we can start creating. I will create, instead of creating the usual controllers, I'll go with like features and groups. Because this will be the backend for frontend, we'll have probably a lot of different things to call different services. So maybe in this case it's a good idea, in the other cases, but at least in this one, it will maybe be a good idea if we split into features instead of having controllers completely unrelated all together. And over here, let's add new controller, Visual Studio Preview doing its thing, API controller, we don't need this because we already added it, and we'll need basically the same as we have on the group service. I think I opened it here, the group service. So let's see on the controllers, groups controller. I'll copy this part because it should be the same. Most of it. So let me just change this here. I'll add this so we can have the signatures. And this one. I'll make this group model. Let's add a group model here. So in the same place, we can add other folders or stuff like that, but I'll keep it simple. Group model, and let me copy the group model. I'll be doing this in this project, but for instance, one thing we could do, and maybe we do it in the future, is imagine for this web API, we can create another project that it is client, and we can create a NuGet package out of it and just share with anyone who wants to call our API. So it's easier for us to control that. And if we want to like upgrade something in our API, we can change immediately the client and give it to someone else, and they have less work, and we are faster doing it because we are doing both the web API and the client. But right now we're going with the simplest part. So we have this and this. Now I will use something that I discovered recently, which is, in this case, we can use, I think it's new on ASP.NET Core 2.2. You can use an action result of T. And instead of doing this, so now we can say that the result will be, or an action result, so we can use the not found and stuff like that. Or we can return the group model, which is nice because it was one of the reasons we could do something like in the update we could do group model, as long as we didn't have to return something like return not found. We couldn't do this because this returns a action result, but now with this we can. So this is interesting. I discovered this week, I think, which is nice. I missed the get all. Here, action result of read-only collection of group model. And this is helpful for something that we'll see in the future, for generating the API's documents using Swagger. Not a topic for today, but we'll see it in a future episode. And here, yeah, in here can be an action result because we won't have any model. So now let's use an HTTP client. We'll see how to configure it later. Right now, let's use the easy part. So we'll create a constructor that gets an HTTP client. So we have an HTTP client. Now you can use it. This will assume that this client already has the base address for the group service. So we just need to map to the routes we want, in this case to the group's controller. So I'll create here a private const string base address groups. So let's make a request. We want to do result, or better yet, response equals await HTTP client dot get async and because we want all, it's basically the base address. And is cancellation token. Now this response is a HTTP response message. We want to get the value out of this, so we can do result equals HTTP response dot read content dot read as async, and we tell it we want. I'm being picky by using a read-only collection here, but it should work. Does this get a cancellation token? Oh yeah. So if we go look at this, this is an extension method. Not great, but okay. The method is, we have out of the box is read as stream, read as string. This is an helper extension method that reads directly to the object. I think for .NET Core 3 they're making new APIs for JSON and stuff like that, so it should improve performance and stuff like that, but right now we have this. So now we have the result, which is what we expect. So we can return result. Let me just check one thing. Can we just do this? We shouldn't, but okay, makes sense. It would need some kind of magic to work like that, but just to make sure. Okay, so we have this. Of course, I'm not handling any exception, which is completely wrong, but let me add here. Which is very likely, but let's keep it simple. Now get by ID, basically the same, mostly the same. In this case we don't want this, and we want there are probably better ways to compose the endpoints, but this works. And because this is a long, we have no problems with while encoding. If not, don't forget to encode stuff. And it's on the route, so be careful of what you put on the route. So this should be it. Now for the update. In this case, the update should be put as JSON async, and we want to put the model. So request model cancellation token. And over here we can do this. I'm forgetting something. So if response status code not found, return and the same here. Over here in the add, post, we can remove this and just post the model. And then we want to do this. And now we want to return, what was the name? Let me check the other one. This one. So we can create it like this. Again, don't forget that we need to handle the errors. Instead of here, I'll put in every place so it's more visible that we shouldn't be as careless as I'm being. The only thing I'm handling is this not found, which is clearly not enough. And on the remove, let me grab the get, because it's basically this one, but delete we don't need anything, return no content. Okay, so this is the easy part. Using the HTTP client, most of you already seen it, I would say, and it's similar even to what we did in episode 15. In that case it was on the front end, but it was very similar. So okay, this is a client, but if we try to run this now, it won't work. So let's configure it. So we have these new helpers, so we can go here, add HTTP client. There are a variety of ways which you can check out in that post I will link. But I think one of the more interesting are the typed HTTP clients. So we can, like, imagine if we want to make a class that abstracts the calls to the group service, we can add the HTTP client attached to that class. In this case, the class is the controller, which maybe is not the ideal, but this is a backend for frontend. I don't know if it's worth it to be creating a lot of abstractions. So right now I'm using directly the controller. In the future, probably we do something else. Right now we go with this. So we can say that we want an HTTP client specifically for the group's controller. So we can just go and add this. And we can just do this, or we can have some configurations. So give it a name. Because when we use the factory, we can ask the factory for the name. Let me show you. So if we had here over here. If we use the factory instead, we have some methods like create client. We can just create a client, any client, or you can pass it a name. So we can like ask, I want the client for groups. In this case, instead of using this, I'm taking advantage of the typed. So it will inject that type to the groups controller, select the appropriate lifetime, and all of that. So we could do this without anything. We can use the name. We can use an action that configures the client, or another that gets the service provider. This is the one we'll use, and you'll see why in a minute. So service provider and client. So this is really the client. So we can configure stuff here. For instance, the base address, we can configure it like this is a URI. Yeah. So we can just create a new URI like HTTP and be done with it. Of course, we can do better than this, and we'll do some configuration, but we can do this. And when we get the client in the group controller, it will be, let me remove this, it will be the client already with that base address. We don't need to put the base address everywhere. We can just do just this. One thing I discovered while preparing for this video is this would work just fine for any other service, stuff like that. But because it's a controller and it's not registered in the dependency injection as the others, we must add here. And this was add controllers as services. So, because if we didn't do this, the controller wouldn't be able to detect this. The dependency injection container wouldn't be able to inject the HTTP client when we configure it like this. But if we do this, then it will work. I'll maybe just comment it so we can see the problem. And let me just put this working. So let's go to the front end, groups. Maybe I need to restart the front end. What about now? What's going on? Stop. Why? What did I mess up? Let me open Postman to see what I did wrong. Let's see. Groups. Port 4 not found. Oh, yes. Yes, no. Ah, yes. That's the problem. We don't have the API. Okay, now it's what I expected. An error, not a 404, because unable to resolve system HTTP client. Okay, so this was expected. Let me close this. Let me restart frontend. And now we go to the startup. We use this one. And now we have groups in this beautiful UI. Now test 2, and it created. So we are doing our requests, we are getting the information, we can update, hopefully. Yep. And can refresh and we get the same, and we can remove. Yep, so it's working as it was, but now we have an indirection. We go to the backend for frontend, which makes the request to the backend. Like I said, it's stupid in this case because we don't have nothing complex. We're just proxying, but when we add some things more complex that need aggregate data or stuff like that, this will be good. Particularly if we have multiple services from where we want the information, this will be useful. If not, yeah, this is dumb, and we'll also take a look at some proxy stuff. Now let's what? I was going to put this in configuration, but as we already talked about configuration, maybe I'll leave it to do afterwards, not really important. Let's take a look at poly. We haven't talked that much about poly, so we can take a look. Like I mentioned at the beginning, poly is a library that provides us with tools to simplify implementation of resilience patterns, like the retry. Instead of us going with a for, trying 3 times, we can implement it here with better support, unless we want to roll our own and do everything ourselves, but probably not needed. We have the circuit breaker, so if we fail a certain amount of times, we don't want to continue hurting the server with requests, so we stop and give it time to take a break. Timeouts to cancel requests that are taking too long. Bulkhead, so we only allow a certain amount of requests. I'm talking requests, but this is generic in poly, but as we are going to use it in the HTTP client, I'm talking about requests. So bulkhead simply allows a certain amount of requests to go through. So if they fail, not everything fails. And other patterns like cache, fallback in case of if something fails, we can provide another option, and all of that. So we are going to use this, but not like directly poly. We're going to use some helpers that were created for ASP.NET Core to configure the HTTP client to use this. So we can use poly directly, implement it by ourselves, but since there are these helpers, for the other way to use poly, check out the old video I did. I will link it so you can take a look if you want, but again, the font is probably a bit small. Okay, so let's start. it's talking here about this ASP.NET Core HTTP client, so we can check it out. Blah blah blah, the story, but I want to use it, so we need to install this package. So let's install it. .NET add package poly extensions. Okay, we can put this on watch again, and then we want to use it. So there are some examples. Now we can add this. We can use this one, or we can do other things. Let's start by using this one. We check. Using poly. Okay. So this basically what we are saying with this configuration, which might seem a little weird at first, but basically we're saying when we have a failure, we will want to wait for 1 second before the next retry. After we retry, if we get another failure, we'll wait for 5 seconds. And then when we retry again, we'll wait 10 more seconds. And after that, it stops retrying. So let's see this working. Over here, let's make a change. Over here in the groups controller, the original from the group service. And let's do throw new exception, just to see it working. So when we try to get all, we'll get an exception. So let's see. If we click, okay, no, go here, and it's making requests. So you see we are getting errors over here, sending the request, and then it got an error. So let's see, we should have 3 retries. So one request was made here, made a request, got an error. Made another request, got an error. And another request, got an error. And the final request, got an error. And in this case, it went for an exception because it retried 3 times and failed all of them. So what more can we do? So this builder, there's more things. So like you can see, the circuit breaker, we won't play around with it. Retry forever, this doesn't seem right. And I think there are other, when I played around I didn't use this method. I think we have more. So yeah, add policy handler. This is specific, but we have this as well. It will do the same, but I think there is policy exceptions no, extensions, which gives us the same, just a different way to do the same. Yeah, I think I like the other way better. It does the same, so but we have a lot more stuff here. Other ways of doing things. For instance, if we, instead of passing an array, we can provide something like, let me see, how was the code? I'll just let's get back to, instead of doing this with the array, we can do another thing like I want 5 retries, and we can pass a function that says time span from seconds attempt. So this means that there will be 5 retries. The first are after 1 second, the second after 2 seconds, 3 seconds, and all of that. Or we could do something like times 2, so the first will wait 2 seconds, the other will wait 4, the other 8, and stuff like that. Or one thing that's also interesting is to add some randomness to this, because if we imagine we have a farm, a server farm, and all the clients are making the retries at the same time, it can hurt the service. So if we try to make the request in a different time, the service may have a little bit more time to breathe and to get back. But if not, after the retries, it will have to get together. Okay, so this should act very similar to what we saw. So let's see the request being made. And slow. How much time did I put? Times 2. So this will take a while. But we are seeing the retries being made, and eventually it will just go out with a final kaboom. So finally, kaboom, as expected. So there's a lot more to Poly, but I just wanted to mention its existence. I think it's worth that mention. So yeah, for more on Poly, maybe we'll get back to this topic. If not, like I said, I already have a video on it. And for the rest, I think we were able to see how to make good use of the HTTP client. An introduction, because we can do a lot more stuff. There are more configurations that may or may not be useful. For most cases, probably what we did here is good enough. But yeah, I think that's about it. Any doubt, as always, feel free to ask. And recommendations for other episodes, like the previous episode was a recommendation, so I'm open for it if it makes sense. And yeah, leave feedback, likes and shares and stuff and all that. And hopefully I'll see you in the next one. See yous.